Hello everyone, and welcome to the official third lesson of our linear systems unit, and this will be the final way that we can solve the point intersection between two linear lines. Okay, so if we're looking at our two lines equations right here, we have the a's and the b's both on the left, our constants on the right, and we line them up as if it's an addition or a subtraction equation. And that's what we're going to do. We're trying to eliminate, just like the title says, either the a's or the b's in order to solve for another equation, just like we did with substitution, but a different method. So we need to first look at the a's because they come first and think, if I add 8 and 5, do I get 0? No, it's 13. 8 minus 5, still not 0. So we can't just eliminate the a's right away. But if I look at the b's, positive 3 plus negative 3 gives me the 0 that I'm looking for. So because I'm going to add those to eliminate the b, I'm going to add these entire lines. 8 plus 5 gives me 13 a's. 11 plus 41 is 52. And then I can just divide by the coefficient, and a is 4. Now I can take that piece of information and sub it into either of the equations at the top. Let's just go with the top one here. So we get 8 times 4 plus 3b equals 11. We'll multiply 32 plus 3b equals 11. Isolate for b by subtracting the 32. And dividing by your coefficient again, and b equals negative 7. So the point of intersection here, we're going to go in order of alphabet, is 4, negative 7. Okay, so again, you're looking to isolate one of the variables at the start. So let's work at this one too. The x's, they have the same coefficient. That's how you eliminate. When you're looking for the variable that has the same, where both of them have the same coefficient. Both x's here have a 4. Well, how do we get to 0 from 4? We subtract 4, so we're going to minus everything here. 7 minus negative 3, remember the minus and negative is adding, so we get 10y. Negative 11 minus 19 is negative 30. We divide both sides, and y is negative 3. Okay, now we're going to take that negative 3, let's plug it into the bottom one this time. So we have 4x minus 3 times negative 3 equals 19. 4x plus 9 equals 19. We'll subtract the 9. 4x equals 10. And when we divide both sides by 4, we get x is 2.5 or 5 over 2. Okay, so point of intersection is 5 over 2 and negative 3. Just like substitution, we want to end up with an equation with only one variable. Using this method, we eliminate a variable by adding or subtracting the equations. Okay, we don't have to worry about this one. And make sure your variables match coefficients before you add. Okay, the reason I crossed out the fill in the blank there, some teachers will teach you to change it so you're always adding. So the variable that has the same coefficient always has different signs, but you guys are smart enough that we can just subtract if, like in this one where the 4x's were both positive. Okay, now a little more difficult because neither our x's don't have the same coefficient, neither do our y's have the same coefficient, so we need to change something. So in order to do that, you're going to choose either the x's or the y's and find a way to make the coefficients match. Let's just choose the y's here. So we have 3y in the top, 4y in the second. So that means that we need to find the lowest common factor, sorry, the lowest common multiple, which is 12. So we want to change the y's to 12. So how did we get to 12 from 3? Well, we multiplied by 4, so we're going to multiply this entire top row by 4. And we'll end up with 16x plus 12y equals negative 4. And how did we get to 12y from 4 on the bottom? We multiplied by 3, so we're going to multiply this entire bottom row by 3. And we get 15x plus 12y equals 3. Good. Okay, our y's have the same coefficient, so we can work with them. They're both positive, so we're going to subtract everything. And we end up with x equals negative 7. Okay, now we can take this x value, plug it into either of the original equations. Let's just use the top one here. So we get 4 times negative 7 plus 3y equals negative 1. Negative 28 plus 3y equals negative 1. We will add 28. And we get 3y equals 27, and then we divide by 3. Y equals 9. Okay, so for this equation, the point of intersection is negative 7 and positive 9.